Good day everyone. In this video in statistics and probability, we're gonna talk about interpreting the mean and variance of probability distribution. Before that, we should know the definition of the mean. The mean of a probability distribution is the result of multiplying all of the variables' potential values by their corresponding probabilities and summing the results. Each represents the predicted value of a relevant variable. In order us to get the mean or the expected value, we should use the formula, and it states that the x sub 1 corresponds to the first value of a first random variable multiplied by its corresponding probability, and that will apply to all the random variables. Add to that is variance. Variance is the expectation of the square deviation of a random variable from its mean. In other words, it measures how far a set of numbers is spread out from their average value. To get the value of the variance, we're gonna use the formula as you can see in the screen. The formula is quite the same in the mean, it's just that in variance, the first value of a random variable is squared, and after that, you're gonna be subtracting the value of the mean. Lastly is standard deviation. The standard deviation is a measure of how much a collection of data deviates from its mean. It determines a distribution's absolute variability. In order us to get the value of a standard deviation, it is quite easy when you get the value of the variance. You just square root the value of the variance that you got. Now we know the definitions of the mean, variance, and standard deviation. We're gonna have some few examples. In the first example, wherein let x be the random variable reflecting the number of dots that would occur with the probability distribution below when a die is rolled. We have 5 outcomes, 1, 2, 3, 4, and 5. When 1 is correspond to 0.4, 2 0.2, 3 0.1, 4 0.2, and 5 0.1. So as to achieve the answer of the first question, which is what is the expected average number of dots to appear, we will be using the formula of the mean, which I said earlier, we just have to multiply the value of the random variable to its corresponding probability. After that, we just have to add it. So it will be 1 times 0.4 plus 2 times 0.2 plus 3 multiplied by 0.1 plus 4 times 0.2 plus 5 multiplied by 0.1, and that will lead to the answer of the mean, which is 2.4. And as the result, since the mean is 2.4, we would assume that the average number of dots would be a number close to 2.4, which is 2. And now let's proceed to the variance. The second question, which is how does the assumed value of the outcome vary from the average number of dots that would appear. In order us to obtain the answer in number 2, we would use the formula in the variance, which we just square the outcome and multiply it by its corresponding probability. And after that, we just subtract it by the mean that we get, which is 2.4 squared. And the answer will lead to 2.04. Lastly, we will get the value of the standard deviation, which we all know we just square root the value of the variance, and the answer will be 1.43. And now we can therefore conclude that the variance of the random variable x, where the number of dots appeared, is equal to 2.04, and on the other hand, the standard deviation is equal to 1.43. And now we will move forward to the second example. The situation is tossing a single unfair die. Probability distribution is shown below. This time it has 6 possible outcomes, which is 1, 2, 3, 4, 5, and 6. And it corresponds to 0.1, 0.2, 0.1, 0.1, 0.3, and 0.2. The following question is just the same in the previous problem. What is the expected average number of dots to appear? We mentioned earlier that we would use the formula of the mean, so we will be following the steps we did earlier, and we will lead to the answer of the mean is equals to 4. How does the assumed value of the outcome vary from the average number of thoughts that would appear? And we again just follow the steps we did earlier, and we will lead to the answer of the variance of 18.1. And lastly, find the standard deviation. We will just square root the value of the variance that we got, which will be the standard deviation is equals to 4. And now we go ahead to the third example. Refer to the probability distribution and associated probabilities for the number of students in one section who will be absent in their summer class in a week. And this time we have 7 possible outcomes, which is 1, 2, 3, 4, 5, 6, 7. And it corresponds to the probability of 0.20, 0.12, 0.13, 0.12, 0.13, 0.10, and 0.20. Keep in mind that the probability is always equals to 1. The first question, which is what is the expected average number of absence will be appear? And again, we will use the formula of the mean, which is 1 times 0.20 plus 2 times 0.12 and so on. And we will lead to the answer of 3.96. And now we know that the mean is 3.96, and since it's closer to 4, we would assume that the 4 is the average number of absence. The second question, which is how does the assumed value of the outcome vary from the average number of absence that would appear? And once again in this question, we will be using the formula of the variance. We will be just squaring the first value of the random variable and multiply it by its corresponding probability. And after that, we just subtract it by the mean that we get, which is 3.96. And the answer will be 20.42. In the third question, which is find the standard deviation, we will be just square it the value of the variance, which is square root of the 20.42, and that will lead to 4.52. Therefore, the variance is 20.42 and the standard deviation is 0.52. And this time, in this lesson, we will be comparing the other data to the following instances are likely to have a larger variance, standard deviation, or variability. In sample number 1, the number of people who attended a concert in a certain state to the number of people worldwide who stayed at home and watched it in their television. The first stanza, which is the number of people who attended the concert in a certain state, we all know that it's much lesser to the amount of people who stayed at home and watched it in their television, and it's worldwide. Furthermore, in sample number 2, which is the population size in a specific country, in contrast to the population size in the whole world, which we all know that the population in a specific country is much smaller than the people who live worldwide. And last sample is the amount of people who participated in a particular project in their community compared to the amount of people who chose to stay at their home. The amount of people who chose to stay at home is much more greater than the people who participated in project. So all in all, we have to keep in mind that the term small variance or standard deviation refers to how near the anticipated value or data points are to the mean. When the variance or standard deviation is bigger, it signifies that the expected values or data points are more spread out from the mean. And lastly, the variance and standard deviation quantify or characterize how spread out set of data or assume random variable values is. And that's it. Thank you for watching, and I hope that you've learned something about it.